Okay, so good morning, ladies and gentlemen. Yesterday we were looking at carboxylic acids, where we looked at the formation of carboxylic acids and their chemical properties. And today we intend to look at a very interesting homologous series which are referred to as esters. Okay, so esters are the ones that we are going to look at today. Esters are also referred to as alkanoates. Alkanoates. Okay, so the other name for esters are alkanoates. Okay, so now esters are widely found in nature. Okay, they are widely found in nature and they have a variety of use. For instance, esters are widely used by manufacturing companies in the production of foods as well as beverages. Or those companies that are involved in the production of foods and beverages, they make use of esters to enhance the taste, or rather the flavor, as well as the smell or the odor of their foods as well as their drinks. So that gives a physical property, or that will tell you the physical properties of alkanoids. Alkanoids, one of the physical properties of alkanoids is that they have a sweet smell. The more reason as to why they are used in foods as well as drinks to enhance the flavor as well as the taste of foods or drinks. Like any other homologous series, esters have got the functional group. Okay, the functional group. It's a group of atoms that distinguishes or that gives the chemical properties for that particular homologous series. Okay, so esters have got an homologous series C double bond O, then O, then R, and even here R. Okay, so this is the homologous series. This is the functional group for the esters. So whenever you see an organic compound with at least this particular group of atoms, then you are able to tell that this particular organic compound that you are looking at is an ester. Okay, so it can also be written as R, which is the carbon chain linked to that particular C double O. Then this is also linked to another carbon chain. So this one is found in the middle. Okay, so this one is found in the middle and then connected to a chain of carbon atoms. Okay, so when you're told to write the structural formula for the functional group of esters, you can write this one. When you're told to write the formula for the ester alkanoids or alkanoids, then there you can write this particular guy over here. Okay, now how are alkanoids formed? Formation of alkanoids. Okay, formation of alkanoids. Okay, so alkanoids are formed when alcohols, or when an alcohol is reacted with a carboxylic acid. Okay, so the reaction between carboxylic acid and alcohol in the presence of sulfuric acid, which is concentrated, in the presence of concentrated sulfuric acid, an ester is formed plus water. Okay, so when you want to form an alkanoates, or alkanoates are formed between the reaction or between the reacting when carboxylic acids are reacted with alcohols in the presence of concentrated sulfuric acid. And of course this will be at a certain temperature because heat is applied there. Okay, so that's how esters are formed. So esters are formed from reacting carboxylic acids and alcohols in the presence of sulfuric acid as a catalyst, and then a water molecule as well as an ester is going to be formed. Okay, so we know that for this particular reaction to take place, or how this particular reaction takes place, we're able to see that one of the products is that water is produced. Okay, so carboxylic acids, or a carboxylic acid that is going to be reacted with alcohol is going to lose an hydroxyl. Okay, so carboxylic acids loses an hydroxyl. So this one is going to lose an hydroxyl, where the alcohol is going to lose the hydrogen atom. So this one loses the hydrogen atom, whereas this one loses the hydroxyl atom. So put together we are going to form water, and this is the water that is produced during the process of forming an ester. Okay, so we can write a skeletal reaction where we know that the structure for carboxylic acid is that. Okay, so this is the simple structure of a carboxylic acid, then, or the skeletal structure for the carboxylic acid, and then the skeletal structure for an an alcohol is this one, then linked to carbon, and then R there. Okay, so what is going to happen is that in the presence of sulfuric acid, this hydroxyl from the carboxylic acid is going to be lost, and then the alcohol is going to lose an hydrogen atom. Okay, so this is the one that is going to come out as water. Okay, so when that happens, then this one is going to be linked to that particular oxygen, forming a compound that will look something like this. So we have R, which is the carbon chain, then there you're going to have a double bond linked to an oxygen atom, and then since here it has lost that hydroxy, it's only remaining with a double bond there, and then here, since it has lost an hydrogen atom, is going to remain with an oxygen, and then that oxygen is going to be linked to that particular linkage or bond, and then you're going to have a C and R there. Okay, so this is what is going to be formed, and what this structure is a simple structure for what we refer to as an ester, or the ester. Okay, so plus the water which was lost. Okay, so this is the structure that we are looking at. Okay, so we can give a good example. We can give a good example. Let's say, for instance, you're reacting methanoic acid, which is a carboxylic acid. Okay, so methanoic acid plus let's say we react it with an ethanol as an alcohol, so plus ethanol, then the products there are going to be ethyl methanoate. Okay, so there we're going to have ethyl methanoate plus water as a byproduct. Okay, and then we are going to get back to how this ethyl methanoate name has come in for the ester. Okay, so our main interest is to see how carboxylic acids reacts with alcohols to form an ester. Okay, so using structures, we know that the structure for methanoic acid is this particular structure. Okay, and then we have an hydrogen atom there, plus we know the structure for ethanoic acid, I mean methanol is C. Okay, so it is 2 carbon, and then it is going to be connected to an hydroxyl, at least an hydroxyl there, and then that. Okay, and then the products there are going to be, so we know that the methanoic acid is going to lose an hydroxyl, whereas the ethanol is going to lose an hydrogen atom. Okay, so when that happens, then you're going to see that the structure that is going to be formed is going to look something like this. Okay, and then that will be hydrogen, and then there we're going to have something that will look like this. Okay, and then there we're only remaining with 2 hydrogen atoms, and then the 3 hydrogen atoms like that, plus water. So the structure for water is written like that. Okay, so this is how the reaction is going to take place. Okay, so this is example number 1. We can also give an example of the reaction that can take place between let's say ethanoic acid and let's say ethanol again. Okay, so ethanol again. So using structures, we can write this one. Methanoic is going to have a structure that will look like this. Okay, so OH there, then there, then plus ethanol, which is OH, then that one there, Okay, so you fill in the the hydrogen atoms there, and then that will be the structure for ethanol. Okay, and then we know that ethanol is going to lose one hydrogen. So the hydrogen that is lost by an alcohol is the one that is attached, the one for the hydroxyl. Okay, so not this one, not this one, not that one, not that one, but the hydrogen for the hydroxyl. Okay, so it is the one that is going to be lost. So you know that hydrogen is going to be lost, whereas the ethanoic acid is going to lose the hydroxyl. Okay, so when that happens, then the ester that is going to be formed, you have 2 carbon atoms like that. Then this is going to have 3 carbon atoms. Then we're going to have hydrogen, oxygen bonded there. Then that one is going to bond with an oxygen for the ethanol. Then you have the 2 hydrogen atoms for the ethanol, and then you can fill in the remaining hydrogen atoms, then plus the structure for water. Okay, so this is how ethanoid alkanoates are formed. Okay, so if you were to name this particular ester that has been formed, it is ethyl ethanoate. Okay, so it is ethyl ethanoate. So that is the name of the ester that has been formed there. Okay, so using this clue that I've shown you on the names of the ester that has been formed, you can you are able to come up with ideas, or ideas can pop up in your minds on how these particular esters are named. So in the next lecture, we'll be looking at how to name these particular esters.